When we hear the term implant, most of us primarily think of dental or hip implants. However, the Fraunhofer Institute for Microelectronic Circuits and Systems researches different types of devices, so-called Theranostic implants, which are designed to make life easier for patients. Engineer Michael Görtz gives us a detailed description.
Theranostic
implants combine the therapeutic and diagnostic functions in one single medical device. This means we have an implant that can monitor intracranial pressure, for example. This measurement is meant to control intracranial pressure via a valve that can be embedded in the implant. This is vital for hydrocephalus patients and allows them to improve their quality of life. The implants contain electronic silicon semiconductor circuit technology, which means they house the intelligent component. Sensor and communication functions are made up in this silicon chip. Needless to say, the implant needs to be well tolerated by the body. You have to encase it in biocompatible metal housings. You must also ensure communication, energy and data transfer through the metal housing. Polymer encapsulations can be used as an alternative in this setting. A theranostic implant like the intracranial pressure sensor can regulate the intracranial pressure. It's an implant that measures the pressure by holding a reader over the implant and supplying it with energy. The implant would then measure the intracranial pressure and activate a control system to regulate the intracranial pressure if needed. In other words, the intracranial pressure is controlled based on the implant measurement. That's the long-term objective of a theranostic implant. Professor Carsten Seidel, who's been the head of micro and nanosystems at the Fraunhofer IMS since February 2019, explains the next steps to achieving this objective. Our current goal at the Fraunhofer IMS is an increased miniaturization of these implants. We want to shrink the electronic circuits even more, make them more energy efficient, and then add the sensors. This is made possible by nano and microsystem technologies. The next steps for the theranostic implants are to further miniaturize the sensors, provide long-term stability of the encapsulated sensors, and, as a third step, integrate more functionality, meaning diagnostic, sensor and actuator technologies. The plan is to also control the valves of the intracranial pressure sensor, thus creating a closed loop. The benefit of closed-loop systems is that patients ultimately don't have to actively adjust and regulate the implant. The intelligent implant handles this process fully on its own. One example of biosensor integration is integrative infection management. This would allow the system to detect an infection in a hip implant early on and counteract it. Fluids could be released to reduce the inflammation, for example.
Fluide abgegeben werden, die die Entzündung minimieren.